Okay, ji. Graph in practical situations, kinematics. Now, when we are talking about kinematics or graph in practical situation in your syllabus, you are more tested about speed, time graph, and distance time graph. So there are two situations that you are dealing in. One is speed time graph. The other one is the distance time graph. So we'll be starting off with speed time graph so that we can directly link this with your distance time graph as well. So considering that you have axis, this is your x-axis, this is your y-axis. Your y-axis in this represents speed, whereas your x represents time. Let's just work upon this. We're starting off with origin 0, 0. Let's say a point is here. Then we mark the point here and then we'll drop the line towards this point. The line will be a straight line. When we are talking about speed time graph, it will be a straight line graph. Considering this and the final line. So what does the line represent in speed time graph? Your lines represents acceleration. This represents the acceleration. This represents the constant speed. Constant speed. When you have constant speed, your acceleration is equal to 0. There's a difference between speed and there's a difference between acceleration. When you accelerate, obviously, then only you will get the speed, momentum to actually, the force is applied, and then in that particular time, you will maintain your speed. Similarly, this point, this line gives me deceleration. This line gives me deceleration. This is also known as retardation. Retardation. So sometime in the question even your deceleration or retardation word is being used. You can even, the examiner can tell you to find the retardation, the examiner can tell you to find out the deceleration. Now, let's just work upon this. If I tell you this is 5, this is 5, this line is 10. Let's take this as 20. From this to this, let's take this as 5. Let's change this 5 to 8 so that we can easily find out the values. Now, what do we see? We see 3 different shapes here, or we can even say 2 different shapes. We can see a triangle, we can see a rectangle, and we can see another triangle, or we can see a trapezium. The trapezium and the triangle, or directly a trapezium. So you can obviously see shapes when you're dealing with speed time graph. So what you will be asked, number one, the first thing that you will be asked in your speed time graph is to find acceleration or deceleration. Now, in maths, your acceleration and deceleration is found out using the formula of gradient. Using the formula of gradient, which means m will be y2 minus y1 upon x2 minus x1. y2 minus y1 upon what? x2 minus x1, which clearly means that your acceleration will be maintained or to be found out using the gradient equation. That means the coordinates will be used. That means the coordinates will be used. Now, using the coordinates here, let's say at this point, this is 0, 0. At this point, this is 8, comma 10. Now, you need to understand that generally your speed time graph is drawn on the white background. It does not contain the graph on it. It will not contain the graph. It will be on the white background, which means you will have to find out the answers through the calculation method. You can't find out anything without calculation. So your acceleration will be based upon two coordinates. Number one is 0, 0, and the other one is 8, comma 10, which means if we use gradient 10 minus 0 and 8 minus 0, which is 10 upon 8, which will be what? 5 upon 4. 5 upon 4. And 5 upon 4 will be 1.2. That means your acceleration from 0 to 10, 0 to 8 minutes, 0 to 8 minutes is 1.2. Your acceleration is 0 from 0 to 8, it will be what? 1.2. Now, generally, there's a high possibility that you might end up having this as reversal working as well. How will you have through the reversal working? Let's just work upon that. Let's say that this is your x, that means this is your time, this is your speed. You know it started from 0, and you know it is based at 8 as time. But you do not have speed. So that means your coordinate is 0, 0, and here it is 8, comma s. Here it is 8, comma s. But now you know one thing, that your acceleration is 1.2 here. Your acceleration is what? 1.2 here. Or the question can directly tell you that the gradient of the line is 1.2. Or it is the acceleration 1.2. So what you can directly achieve through the gradient formula again, which will be y2 minus y1 upon x2 minus x1. But this time this should be equal to what? 1.2, which means s minus 0 upon 8 minus 0, which is equal to 1.2. So s will be what? 8 multiplied by 1.2, and s will be what? 10. So in this way, you can either, the examiner will give you the direct method of finding out the acceleration, or the examiner can test you through the reversal working to find out any given coordinate, and using that coordinate, you will be able to find out the speed or the time that is required for that particular, because the question does not have graph in the background. The question will be at the white background, and you will have to find it through what? The entire calculation. Now, let's just work upon few things. Let's say that now, considering the same thing, if we say, what is the acceleration here at this point? So you should be knowing that the acceleration of this line is 0, because at this, the object is moving. The object is what? Moving. The acceleration is still there, but automatically the speed is constant. The speed is constant. Since the speed is constant, that means from here till here, the acceleration was obviously at the point that it was constant acceleration of 1.2, and with that you maintain the speed of 10. Now, since the acceleration is being maintained at 1.2, further the acceleration is 0. That is the reason the speed is obviously maintained at 10 as well. Moving down, let's say at this point, you can see there is a deceleration, which is also known as what? Retardation. Now, there are few things that are very important here when we are working down for deceleration. Again, deceleration will be based upon the calculation through the gradient method as well, which is 20, 10 and 25, 0. Let's say 20, 10 and 25, 0. Right? Because these were the two coordinates when the deceleration got started and it will go till the end. So at that point, if I calculate the gradient 0 minus 10 and 25 minus 20, which means minus 10 upon 5, this is minus 2. So that means the gradient is minus 2. It shows that obviously there is a decline. If the gradient is positive, it means there is an incline. If the gradient is negative, it is a decline. That is for sure. But now the most important thing where students lose mark. When you'll be writing down retardation, or when you'll be writing down the same thing as what? Deceleration, you will be writing down it as 2. You will not be writing you will not be showing the sign of the deceleration or retardation. You will not be showing the sign of the deceleration or retardation. Now, there can be few questions with the help of retardation or deceleration as well. The few questions can be, let's say the coordinates were what? Let's just draw the graph for the further difference. Let's say this is your graph. The graph was based like this. This is your time, this is your speed. We already knew what we were calculating. This was 25, this was 20, and this was 10. So this is 20, 10. This was 25, 0. And the deceleration that we took out was 2. Deceleration was 2. Now let's say we do not have this 25. We do not have this 25. So if we do not have this 25, so what does that mean? This means that the examiner will ask you what was the time when object stopped. What was the time when the object stopped? Now what you know is that at this time you do not have t, but you have what? 0 as what? Y coordinate. Because at this time the speed is what? 0. Because if it is stopped, the speed becomes what? 0. But the examiner will tell you that your deceleration is 2. The examiner will tell you that your deceleration is 2. So in the same respectful manner, what we do is we'll write down 20, 10. We write down t, 0. And we write down we write down what? Deceleration as 2. But now what you need to understand is that the deceleration, when you will be writing down with the respect to the gradient, now you know that deceleration is there and the deceleration is given to you. But you will, from your own end, introduce the negative sign, which means you'll write this thing as 0 minus 20, 0 minus 10, 0 minus 10, and this will be t minus 20 is equal to minus 2. You'll be writing down this as thing what? Minus 2. So that when you'll calculate it, your t becomes positive. Your t becomes what? positive. This means minus 10 is equal to minus 2t. And obviously this will become minus 2 into 20 becomes minus 2 into 20 becomes what? Plus 40. Right? So what does this mean? This means that plus becomes what? 30 plus negative, it becomes what? 50, right? If it goes on the other side, negative 10, negative 40 is equal to what? Minus 2t. So in this shape, what you will have an equation of negative 50 upon negative 2 is equal to t. Negative, negative can, t becomes what? 25. So you end up having the same answer as we started off with what? 25. But in this case, obviously, since the t was not given, we found out using t through the deceleration. The concept here, what I was more focusing was that when the examiner will give you deceleration, the examiner will not give you the sign of the deceleration. You need to introduce the sign yourself. And even when you will be writing down deceleration or retardation, you will find out the gradient. You will end up gradient in the negative sign. But when you are writing down the answer, you will not be writing down the negative sign because deceleration itself means decline. So declining at what speed? You'll say that you are declining at the speed of 2. That means you are going down. Now, moving further, what else we can be asked in the same topic? Or what else we can be asked in the graph of speed time graph? The question the examiner can ask you, what is the speed when time is equal to 5? Now, let's just draw the graph again because we had that drawn. This is your time. This is your speed. Your graph was like this. The values were 8, 20, 25, and 10. Now, the question is, since you know that it is a white background, it does not have graph on it. So, when time is 5, now where does time 5 lies, you do not know. Does it lie here? Does it lie here? Does it lie here? Does it lie here? Even if you know it lies here, what will be the speed? You do not know here. So in this way, what you're going to do is, you can either use the gradient method or you can use the equation method. For me, I would always prefer using the equation method because you will find out the equation as well. Your coordinate geometry could be enhanced in this topic too. So that means, let's find out gradient 0, 0, 8, 10, which means 10 upon 8. So 5 upon 4 becomes the gradient. Your equation of line y is equal to mx plus c. Remember, y minus y1 mx minus x1 is not used in your O levels, math syllabus. So y is equal to mx plus c, which means y is equal to 5 upon 4x plus c. Since it is passing through the origin, the equation becomes this. So your y is s and your x is t. Your y is x and x becomes t. So now t is 5. So what will be s? So s is equal to 5 upon 4, 5. So this becomes what? S becomes 25 upon 4. S becomes what? 25 upon 4. This will be somewhere closer to what? 6.24, 6.25. So your speed is what? 6.25. So at this point, when, let's say, when time is 5, you got to know that your speed is what, 6.25, which you cannot solve or you cannot get if you are just randomly doing it. So you need to find out the equation, and your equation will be through what, y is equal to mx plus c. Your y represents speed, your x represents time. Right? So when you know that t is equal to 5, we substituted t is equal to 5 to find out speed. And similarly, the question will be based upon when the speed will be given, and you will be told to find out what? Time. Now, with the help of speed time graph, the third thing is to find out the distance. With the help of the speed time graph, now you are finding out what? You are finding out the distance. That means distance in the speed time graph, distance in the speed time graph is basically calculated through the area under line. Is calculated with area under line. Now I'll tell you why the increasing acceleration or decreasing acceleration is not used in your O-level math syllabus, because when you're calculating the area of the increasing acceleration or decreasing acceleration, you will have to calculate it through the integration method. And integration is not part of your O-level syllabus. Anyway, so working down the distance of the speed time graph here, let's say that we have the graph again, and the graph goes like this. We are just maintaining the same graph. So this was 8, this was 10, 20, and 25. So if I want to find out the area under the line, that means I can even calculate through the different shape. Let's say that I want to calculate my distance when this time is 8. So that means for this, I need to calculate the area of the triangle. So when I calculate the area of the triangle, so I know from here to this point, the base is 8. And from here to here, the height becomes what? 10. Because this becomes your triangle. The base becomes 8, the height becomes 10. That means from this point to this point. Now you need to understand this. If we are finding out the area, that means we are finding out half into base into height, which is half into 8 into 10. So the end result is what? 40. So your end result is what? 40 years. So what we know is that the distance that we calculated from 0 to what? 8 is 40. Now, let's just say we need to calculate the distance till 20. Calculate the distance till when the time is equal to what? 20. So what we can do is, if we want to calculate the distance, we have already calculated the distance of 8. So what is the difference between this? So that means the distance time is 12, and this is what? 10. And this is your rectangle. So 12 into 10 becomes what? 120. So if we just write down this thing, which clearly will give me the shape, this is your rectangle, right? The difference of 20 and 8 is 12, and this becomes 10. So that means area from time 8 to 20 is rectangle L into B, which is 12 into 10, 120. So if this is 120, total distance will be 40 plus 120, which is equal to what? 160. So that means you know that the distance that you are calculating, that means you know that the distance that you are calculating till 20 is 160. Now you can also calculate using the trapezium method. You can also calculate using what? Trapezium method. And how do you use trapezium? Height into what? Sum of parallel sides. So height half into height is 10 into what? This the sum is what? 20 plus what? 20 plus 12. 5, 20, 32. So 32 into 5 becomes what? 160. So using the trapezium method, what you got distance was directly as what? 160. You can even distribute into two equal shapes, or you can do it through the trapezium method too. The distance that we need to calculate through what? 20 and 25. So in this distance from 20 to 25. So that means half into 5 into 10. So that means this will be 25 using the triangle, right? So the base is 5, 20 and 25 difference is 5. And the height is what? 10. So that means the total distance will be 40 plus 120 plus 25, which will be equal to what? 185. The total distance will be what? 180. Now working on reversal using what? Distance. Let's say that the graph is like this. The graph goes like this. This is 8. This is 10. Find out time when distance covered is 160. Now see, you need to reverse working through this. Now at this time, what you know is your distance is what? 160. What is your distance? Your distance is 160. But you do not know the time where the distance will cover at what? 160. But you know one thing, normally 90% of the time your distance is through the trapezium method. That means let's say this is even given. Let's say this is given as 15 here. Just a random 15. Now, even at this time, you do not know that is it before 15 as t or after 15 as t. But what you actually know is that obviously the first part will be cleared because the first part is the distance is what? 40. 8 into 10 divided by 2. The distance is 40. That means your distance will be covered in the next part after the triangle. And after the triangle, what you can see is trapezium. Now, even if this can be before t or after t, it does not really matter. After 15 or before 15, it does not matter because even before 15, it will be marked as t, or after 15, it will also be marked as t. So even we should remove this from our mind, even if there is some value given here. So let's just work down with the value as t. So what you know is that the height of the trapezium from here till here is what? 10. Your one parallel line value should be what? T. You need to focus here. Your one value line should be what? T. But the other line is T minus 8. The other line will be T minus 8. So your area of trapezium formula is half into height into what? Sum of parallel sides. So that means half into 10 into t plus t minus 8. And the area will be what? 160. which will be 10 divided by 2 is 5. And this will be marked as what? 2t minus 8. 160 divided by 5 will become what? 8, 18, 16. 160 divided by 5 will become 20. 160 divided by 30, 30, 32. And then plus 8 is equal to 2t. 40 divided by what? 2t. So what do we have is t. So t becomes what? 20. So what we know is at this point the t is what? 20, where the distance will be what? 160. So if you just look at this, the time was what? 20 when the distance was what? 160. So there is a possibility every time that the examiner will test you through what? Test you through the same method, that the distance will be given to you and they will be telling you to find out the what? Time. In the similar state, in the reversal, there might be a possibility that the height is missing. But at that time, the time will be given to you. So there would be one thing that would be missing. There is a possibility that the examiner can test you through the different variables. They can tell you that, okay, the speed is twice when the distance is covered. So every time when you'll be solving down the question, you will end up having the different scenario related to the speed and the time, but you'll be able to solve it through if you're able to understand the question. If you're not able to understand the question, then automatically you will end up getting the things wrong. This speed time graph is directly linked to the distance time graph. Now, what we know is, let's just write down this thing. What we know was, using the speed time graph, what we know was from 0 to 8 minutes, the distance covered was what? 40. From 0 to 8, your distance was what? 40. From 8 to 20, your distance was 120. From 20 to 25, your distance was 25. So total distance when we'll be working down, total 40, 40 plus 120 becomes 160. 160, this becomes what? 185. So this is your total distance, where this is your distance covered through what? 0 to 8, 8 to 20. But what you need to understand is, just like cumulative frequency curve, you'll be drawing the distance time graph as cumulative frequency. That means at 8, you'll be writing down 40 total. At 20, you'll be marking what? At 25, you'll be marking what? Because when you're doing distance time graph, that means that you are dealing with the total distance. So if we just draw the graph, now this graph will generally be linked to the time and the distance. The time was 8, 20 and 25, right? From 8 till what? 40. Now, what you know is that we have this curve 40, 80, let's say 120, 160 and 200. Just drawing the graph, obviously if the graph is not there with any values, you can mark your values accordingly. From 8 to, at 8, the distance covered was what? 40. Now you need to understand, since it was what? Acceleration was there and the speed was increasing. The acceleration was there and the speed was increasing. That means the distance covered will be in the increasing motion. It will be curve. So that means when the speed is straight, incline, the distance covered will be the curve. At 20, what was the, at 20, the distance was what, 160. And if you note, your speed was like this. Your speed was constant. So when the speed is constant, you will be marking this as straight line. You will be marking this as straight line. And when there is what in the last phase, if you know that there was what? Deceleration. There was what? Deceleration. That means you will maintain yourself to what? 185. So from here you will be marking like this. So decreasing motion. So at this time you will be having increasing motion. This will give you straight line because of the constant speed, and this will give you your decreasing motion. There is also so at this time what you need to understand is that there is a possibility of the rest as well. So the rest can take place from here if the situation is finished, or the rest can be taken place here as well, right? So what does distance time graph gives me? Distance can also tell me the speed using the gradient. Remember one thing, gradient of straight line is easier to calculate. But how do you calculate the gradient of the curve? You will be drawing the tangent here. At the point where you will have to find out the speed or the distance, you will be finding out what? You will be drawing the tangent. The tangent can be drawn here, the tangent can be drawn here. Then you need to pick up 2 points on the tangent. Those 2 points will be what? Used to find out the gradient. Even when we are linking ourselves to speed time graph, there is a possibility that you might be given the speed time graph. There is a possibility your speed time graph can be in the curve, increasing acceleration. So increasing acceleration, gradient will give me what? Acceleration. So when the increasing acceleration tangent will give me my acceleration. You cannot find out the entire curve acceleration. From at that point on the curve, you can find out the acceleration only using the gradient method. So this was all about what? Kinematics, where you will be asked speed time graph and the distance time graph. Last thing, you will be asked to calculate speed. Your formula for speed is distance upon time. But remember, there is a difference between finding out speed and average speed. To find out average speed,